Hi guys, this is Ram from Great Learning. I hope you guys have a nice day so far, and I hope you will have a better day after you watch the session. Okay, guys. So basically, in today's live session, we'll be doing Docker for Windows. So all of you guys who know about Docker already, I'm pretty sure you guys are excited to know how to use Docker for Windows because whenever we work with Docker, we normally work with Linux itself. We never work with Windows. So in this session, what I will do is I will go through Docker in brief, and then we'll go ahead and try out Docker for Windows. So a disclaimer will be mostly using Docker for desktop, but I will show you how you can go ahead and download Docker toolbox. If you're getting confused, it's all right. Don't worry. I'll give you guys all the steps. So, guys, before I get started with the session, what I want you to do is go ahead and give me a confirmation in the chat because I want to make sure that you guys can hear me properly. All the settings are fine. Like if you can hear me loud enough, and if you guys can see my screen. So go ahead and give me a confirmation. And while you guys are giving me a confirmation, it's gonna take some time because we have a lag. So I'm gonna show you guys something. So, guys, here at Great Learning, yeah, we have started this initiative called Academy. So, if you are interested in getting a certification for free, go to greatlearning.in/academy. Why? Because we have started to give out courses for completely free. So we have a lot of different courses and live sessions over here, and we're giving them out for completely free. You can see a lot of different types of categories like data science, machine learning, artificial intelligence, IT and software, cloud computing, marketing and finance. We have a lot of different courses. You guys can go ahead and check these courses out and enroll for them. It's completely free for you to enroll. You don't have to pay anything extra, and these courses can be from 3 to 6 hours. They'll definitely help you out to get the basic understanding, and you will get a certification at the end of it. And if you don't want to type in the URL, you can just type in Google Great Learning Academy. All right, so with that out of the way, I will check the chat right now. Let me open it up. I have it open up on my phone. Right. Okay. So good response. I'm seeing a lot of people typing in yes, hello, hi. So that's good, guys. Keep on asking questions. Wait. Yeah, so make sure to ask questions in this live sessions because that's the main point of this live session is to answer your questions. So feel free to ask anything and I'll try to answer them, okay, while I'm giving the session. All right, so for all those who are beginners or just looking to get into Docker, we're going to go through a lot of briefs of what Docker is. And so we'll first, go through the issues we face before containerization. Then we'll talk about what is a container. Then we'll talk about container versus VM. Why do we need containers? What is Docker? Installation and setup in Windows, environment, common commands, and architecture. So, guys, what I'll basically do is I will try to go through the Docker parts faster because I'm pretty sure a lot of you who have logged in are, already experienced with Docker. If you guys are experienced with Docker, please go ahead and type in the chat. Or if you've heard about Docker from before, go ahead and type it in the chat. So I get an idea of who all know about it, and should I be going into more detailed view of Docker, or should I be concentrating on the Windows part? So I'll just wait. There's a little bit of lag with the chat. See, if I get no reply, see if I get no reply, what I'm gonna do is I'm gonna do it my way. That is, go through everything detail. All right, so I'm seeing a lot of people say that it's they want in detail what Docker is. All right, okay, fine. I'm seeing a lot of people who are saying that they're new to Docker. All right, so that would be interesting because we normally when we work with Docker we work with Windows, Linux, but today we'll be working Windows. All right, fine. Let's start. So first we're going to talk about the issues we faced before containerization was the thing. But why are we discussing this? So let me give you guys an idea that Docker, right? It's a tool that helps us in software development. Now, what do you know about software development? Software development is basically developing software. Now, if you look at the process, right? there is a very standard process that a lot of companies form their pipelines upon. Like, let's say this is the standard delivery pipeline where you are developing software. So this is like the basic process. If you guys learn how to develop code back in college, or if you've done it as a hobby, you just done it like, write your code, put in the compiler, and then execute it. So after you executed it, you get some output, and you're happy. But that's not how it works in software development. Software development is a very a hungry market. The software field itself requires a lot of experienced, skilled people, and they need to churn out software pretty fast and very high quality software. So for that thing, we come up with a pipeline similar to how we have in automobile industry or any other industry where you have a lot of processes and pipelines in place. Even in software development, you have like a pipeline set. So you can see here the developer writes the code, and once he finishes writing his code, he sends it ahead for the building process and for the testing process. So when the developer sends his code ahead for this whole process, he sends it with the dependencies. Now, what are these dependencies? So if you guys know what dependencies are here, basically dependencies mean like libraries or functions that you use with your code. So let's say you're using some mathematical functions with your code and you need a specific library for that. So that library is a dependency for it. Or if you need a specific tool for your code to work, then that's a dependency. So when you're building your code, it's different than running the code. Why? Because in building the code, you're creating an executable file. So if you guys have worked with Windows, which I assume that most of you have, you will see that whenever you download a program and when you install it in your system, there is something called a .exe file. The shortcut is always like the .exe file. Now it's like that because that's the executable file. So it has everything that the software needs to be executed as an application, not just the code, but everything else that is also required for the code to run. So that is the building process where you build the code with all of its dependencies and you make a single executable file. Now we create this executable file because we want the tester to run it in its running state, in the dynamic state where it takes in values and inputs and all those different things. So that's how we build it. We give it to the tester and the tester starts testing us for different things. Like he starts testing it for more about whether it's working well or not, like whether it fills all of its requirements. Let's say that we created this application to help blind people. So like, is all the audio quality working? Like, is the audio quality fine, and is it working at all or not? So those kind of tests the tester would do, and he would check it for integration tests, whether it fits well with the other parts of the software, and he will check if it works fine by itself, and if it doesn't crash when we give it some certain inputs. So let's say we've designed a code in such a way that it takes only in certain inputs, but as a user we don't know that that the code has been designed like that, so we might enter anything. So that's where the tester has to go with that mindset, that a user can put in anything, so he should be testing it thoroughly. In the end, what the tester does is he either approves the code or he notifies the developer that there is this mistake, that there is this bug. So the developer takes in the feedback, he improves the code, and then he sends the code again for building process. Now the tester, right? So the tester's job again comes to see like the code, and if he thinks it's good for deployment, he sends it for deployment. Now in the deployment, basically what we do is we establish an infrastructure. This can be your servers, and inside of those servers we launch the software, and then we make it available to the public so the end users can start making use of it. So this is a very standard delivery pipeline. Now there are some issues that can occur with this standard delivery pipeline. Okay, so I see there are questions coming up in the chat. So what is deployment? All right, Charles. So deployment is it's like deploying. So let's take the example of war. In that you have the soldiers being deployed to the front so that they can start fighting the enemies. Similarly, in software, you deploy the code so that the software can be used by the end users instead of fighting is just being used. So if you're watching YouTube right now, the YouTube software or the application has been deployed so that you can start making use of it. It's in production, like it's in the final environment. All right. So now we have an basic idea of what a standard delivery pipeline is. Now, what kind of issues can occur in this? So there is one issue that I'm going to talk about, and that is the compatibility issue. So when does that occur? So to understand when that occurs, we need to look at the developer's environment and the tester's environment. So if you look at the developer's environment, you have a lot of different things. Like you have the operating system, you have the PyTest 5.4.3. This is a testing tool. Then you have an integrated development environment where the developer writes his code. Then you have the backend code itself where you are writing the code, and you have the dependencies. So you have a lot of different things in the developer's environment, and he needs all of these different things to execute his code, to make sure that his code is running. And if you look at the tester's environment, we see that the tester has a similar environment where he has the same operating system. This is a CentOS operating system. And he has similar tools, but they're slightly different version. Like PyTest is not of the same version. It's a little bit different. And the integrated development environment he's using is a little different, but he's working on the same code and he's working on the same dependencies. But the thing is that, the code runs fine on the developer system, whereas on the tester system, it does not run fine. Now, that's a big problem because you're using the exact same code and the exact same dependencies. So why is this issue coming up that the code is running on the developer system, but it's not running on the tester system? So that's where, again, the environment comes. So let me bring it up again here so you can see the differences. So the differences are the IDEs are being used are different. The developers using PyCharm, the testers using Spider, and PyTest 5.4.3 is being used by developer and testers using 5.3.0. So this is where the slight differences come up. And when slight differences come up, your code may not run because the code is very fickle like that, where software is very fickle like that. Some versions run everything, some version won't run even a single thing, and some version might run half the thing. So we need consistency across all our systems, especially in software development process, so that we don't have these kind of compatibility issues. So to maintain the standardization of everyone having the same development environment is difficult because your requirements will change as a specific team member. As a developer, he might have had the same environment before, but he changed his environment because his requirement asked him to. What was his requirement? Maybe his requirement asked him to have the latest version of PyTest, so he downloaded it and he made the code work. But the tester wasn't informed about the same thing. So that's why the issue occurred. So to basically rectify or to mitigate this compatibility issue, what we do is we introduce containers. So containers, right? What they do is they basically are environments of themselves. So let's say you have three friends, and these three friends want to basically assemble a toy. So what they do is they take a box and they put the toy inside of that box. Now the first person, right, he attaches the first part. Then what he does is he closes the box and he ships it to his second friend. Now the second friend opens the box and he also fixes another part to it. Now he's done his part, so he closes the box again and he sends it to the third person, the third friend. Now the third friend also goes ahead and fixes a third part. So this way, the whole toy is assembled. Now it feels a little bit nonsensical. Why is he sending toys over and all? So this is to give you guys an example. Similarly, in software development, right, we don't send the code. Like when we use containers, we don't send the code directly. Like we're not copy pasting the code, or we're not giving the GitHub links to our friends or our testers. What we are doing is we are creating containers, and inside of these containers, we're keeping everything we need for the software to run. What is required for the software to run? We need the code, we need the libraries or the dependencies, and we need the tools that make it run. And also we need the environment. So you have four things: the code, the dependencies, the tools, and the environment. This environment can be an operating system like Ubuntu, Windows, Mac OS. It can be those kind of environments. So you take all of these four things, you put it inside of a container, and you ship this container across the development pipeline. Now, the pipeline I gave you guys is a very simple one where you just have like two people. But in a very large company, you might have a lot of different people working on the pipeline. And that way, a lot more compatibility issues might occur. To stop that, we use containers, where we are sending the container instead of the code. Since we are sending the container, all the settings and configurations that are needed to run the code has already been configured by the developer. There is no need for the tester to go ahead and do the same thing. He just needs to work inside of the container. So if we are executing the code, if we are testing the code, all of those processes will happen inside of the container. And if it happens inside of the container, it does not need to interact with the outside system. And if it's not interacting with the outside system, no compatibility issues, no bottleneck in the whole pipeline, and the process can go on. The tester can test it and he can send it towards deployment or production environment, where the end user can start making use of the product. So this is what containerization helps us to resolve. It helps us to resolve the problem we had with the consistency of environment, where everyone was not able to maintain a standard environment that was causing compatibility issues. Then we started using containers, so the environment was inside the container itself. So there was no need to change the host system, the laptops these people were using. All right, so that's what containerization does. Now you do it with containers. So what is a container? So container is basically like a box, like the box I told you guys about. So it's like a container. It's like a shipping container itself, and that's how people even imagine it. So that's what they call it, a container also. Now, if you go for the proper definition of it, containers are basically software that wrap up all the parts of the code. Wrap up basically means contain all of the code, and all of its dependence into a single deployable unit. So as you guys can see here in the diagram, we have the code, we have the libraries, we have the environment. All of them is taken together and put inside the container. So once they're inside the container, they can be shipped anywhere and they can be executed anywhere. So that's what a container does. Now, you can compare containers to virtual machines. So if you guys have an idea about what virtual machines are, you will get a better understanding of what containers are. They're kind of like virtual machines, but they are very, very lightweight when compared to virtual machines. So virtual machines, I hope you guys really know what virtual machines are, because then it's going to be a lot of trouble to explain the whole thing. Okay, so if you don't know what is virtual machines, that's all right. Forget whatever. But just remember that containers are used for maintaining consistency. But for those who know what virtual machines are, their containers are similar to that. They're basically emulating an environment, a self-contained environment. So let's compare these two. So if we look at a container versus VM, we'll set some criteria. These are the criteria. So let's start comparing them. Okay, so in container, right, and in virtual machine, you install operating systems and you make them run. So what's the difference when you do it with container VM? With container, you only use the bare minimum parts. What this means is that, Windows or Ubuntu, all of them have very large graphical user interfaces. So yeah, you guys are right. I can see in the chat that someone said that they know. So that's good. So in containers, right, you have very bare minimum parts of these operating systems. So let me go ahead and show you my operating system. So this is my operating system. This is my kick-ass wallpaper. And this is all the GUI where I'm moving the mouse, where I'm using PowerPoint and everything. I have a lot of different tools over here at my disposal. But in a container, you don't have any of it. You just have the bare minimum processing, like all the kernel, all the main things that the core part of an operating system. So that's what you have inside of a container. Whereas in virtual machine, you have the whole thing. So that's the difference, where containers only keep the bare minimum parts, whereas virtual machines have the whole thing. Now, virtual machines are more generalized for generalized purpose, whereas containers are specifically developed with the software development in mind, where people just want to develop software, and that's why they've designed it. So it's built by developers for developers, containers. All right, so I hope that was clear. If you look at the architecture, you guys get a better idea, where you can see that the containers, right, they are inside of the host operating system. They don't act as a separate entity or anything. They share the same kernel, they get the resources from here, and they have their own apps and services inside of the container. And the isolation, right, it's not as much as the VM has. It has some isolation, but not as much. And you can see with the host and virtual machine, with the virtual machine, it's completely separate. Like, it doesn't even share the kernel. It needs to make use of something called Hyper-V to utilize the resources from the hardware. So you can see the differences, clear-cut differences in the container and virtual machine with these architecture diagrams. So someone's asked, does using containers utilize a lot of RAM? Actually, if you're comparing it to virtual machine, no, not at all. But if you're launching a lot of containers, I mean, that's common sense, they'll start using more. But I assume your question was the first thing. Why is Docker so fast to launch a container second? Okay, so when I compare this, right, so you guys will get a better idea. So, okay, so we have the isolation. Like I told you guys before, the isolation provided by the containers isn't as complete because it shares the kernel. Whereas with virtual machine, it is completely isolated. So if something happens to the system, I mean, like a malware or something, it will not affect the virtual machine. So it's a lot more secure. All All right, so if you talk about efficiency, again, a lot of people have asked me why is containers were more efficient. Now, containers are way more efficient than virtual machines because containers are very lightweight. They only contain the bare minimum parts versus the virtual machines that have the whole thing. So containers, right, they utilize only the resources for whatever is necessary. They won't utilize the resources for the whole graphical user interface or like apps like VLC or Windows Media Player. It's all not needed, or it's not all, at all needed. Whereas with virtual machine, you will need the resources to run them. So in containers, you can see that they're very lightweight and they can be run way more easily. All right, so if you look at portability, you can see that containers are more portable because they're self-contained environments that they're designed for portability, where you can shift a container from one system to another system. So it's very easy to do so. Whereas with virtual machines, it's not that easy. You can do it, but it's just not that easy. So a win for container. And scalability. So when we're talking about scalability in software development, you have to scale your software. That means that you have to increase the amount of servers you have, so that if you have a lot more people using your service, then you need to expand your service. So for that, you need scalability. You need to add more containers running more software, so or more virtual machines running more software. So that way, again, containers win with against virtual machines because virtual machines aren't really that scalable because they're very heavy in nature, whereas containers are very lightweight, so they can be easily added or removed. So it's like an on-demand service that you can make use of. And again, deployment, where you're deploying the software. Containers you can deploy using the Docker CLI, that is the command line interface, that is all the Docker commands that you make use of. And you can make use of cloud services on AWS, Azure. These are cloud platforms like Amazon Web Services, Azure. They have their own container services where you can launch containers, you can deploy them and make use of it. With virtual machines also, you have similar cloud services, or if you want to do it on a local system, you can use PowerShell or something called Virtual Machine Manager. So guys, that was the difference between containers and virtual machines. I'm going to skip this part because I know a lot of people who are here will get confused. I'll talk about this later. So again, why do we need containers? So there are two reasons. I've already listed one reason. Guys, give me a second. All right, so I have a question in the chat. Someone's asking what is a kernel. So kernel is like it's like the core part of your operating system. Like it's responsible for things like managing the memory of the whole thing, doing all the tasks, process management, like the space management, disk management, all those kind of things. That's like performed by the kernel. So all the heavy technical stuff. Why is Docker on Windows has issues while overusing on Linux was easier? Well, that's a question I can't go into detail, but from what I know, Docker on Windows is something you have to work a little bit harder on, because when we talk about software deployment, not everyone does it on Windows servers. When you do deployment of software, it's generally done on Linux. Uh, so that way, it was more developed for Linux rather than Docker or Windows. But it's not the case that people don't use it for Windows. They do make use of Windows. How do you install Docker on Red Hat Linux 8? Okay, so there is a whole step. You can go ahead and check it out in the documentation. If I list down how to install it in Red Hat, it's going to take the whole session, and I want to give you guys a better idea of using containers in Windows. Okay. All right, so for those people who are going to watch this video after it's been uploaded, you can skip to the practical part if you already know about Docker. And there I explain how to download Docker for desktop. All right. Coming back, so we're talking about consistent development environments. So containers help us resolve that. I've already told you about this, not going to repeat. And then we have microservices. So microservices, you guys have to understand, in software development, we don't deploy like one single file. We write the code in one single file and we don't deploy that. What we do is we take the software, we divide into multiple chunks. Like let's say we have one software for delivering food app, or let's take a better example. I've used that example way too many times. So let's say you have a mattress company and you want to create a website for it. On that website, you have a lot of different features where you can scroll through the mattress, browse through the mattresses, have a cart, you have a payment feature, and all those features. So all of those features together combine to make the software, right? The website. So what you do is you take all those features and you put them into separate containers. You do this and you deploy all of these containers together. So what this does is, this basically helps us to manage the whole service, the whole website way more easily, because we have divided all the features into single parts. This way we can easily assign development teams to work on single features, and it allows us to basically, keep a more robust system. So, suppose you want to increase the availability of your software. Availability means that, make sure that the customer can use it all the time. It doesn't crash or anything. So for that, you need to have certain replicas of your services. So it helps in that process also. So basically understand that microservices architecture is dividing a software into multiple manageable chunks and deploying the software as such. Like you guys can see the diagram over here. We might have one feature in this, one feature in this, one feature in this, one feature in this, and one feature in this. All of them are connected together, and they might have dependency on each other. So they are definitely connected to each other, and then they'll be deployed as a whole. All right. So these are the two reasons why we need containerization. So what is Docker over here? I finally come to what is Docker. Thank God. So what is Docker? So Docker is basically a tool. It's an open source tool that helps us to deploy, to create containers. We've learned about containers. Docker helps us to create these containers. Okay. So you have a Docker, you use Docker to take an application and you put it inside a set of containers and you deploy it. So that's what Docker does, helps us to do. It helps us to create and manage these containers. And it also helps us, it creates a layer of security over these containers so that someone with unauthorized access can't access your software unless, you authorize them to. Okay, so why Docker? So I'll quickly go through this. So they say it's simple, fast, easy collaboration, built for developers, and Docker community. So Docker was developed by a bunch of developers thinking that, development should be much more easier. So they came up with something that was simple. Yes, Docker is very simple to learn. You can learn it in 1 hour. It's very fast. Yes, you can deploy containers really fast. And easy collaboration. Yeah, you can share your containers / images with other people pretty easily, and it's built by developers for developers, and it has a very large community. So a lot of people keep on contributing to Docker community, like a lot of plugins, a lot of images, all of that, community supports. Is Docker, so Piyush asks, is Docker a tool of DevOps? Yeah, you do use it in DevOps. So DevOps principle, right? Docker really fits really well with that whole principle of DevOps. In DevOps, you want to automate the whole process. You want to make sure that everything is as optimized as possible. So Docker is definitely used or is a part of DevOps. All right, but it's not like it's exclusive to DevOps. You can use it without DevOps. If you as a person don't work in software development, you just want to launch one of your applications. Let's say you want to launch Ubuntu. You want to play with Ubuntu because you're bored. So you can use Docker to launch Ubuntu, and you can start playing inside of it. So it's not limited. So why Docker is fast? I've already answered this. So Docker, right? It's Docker itself isn't fast. Like the containers, right? That you create with Dockers, they are very lightweight. So it's very easy to download them. It's very easy to create containers out of them, to deploy them, and it's really easy to stop or kill them, right? So that's why they're so fast. Okay, so let's go ahead and install and set it up. So someone's asking, can you please show how to create a custom image and share it, right? So I'm gonna quickly get to that. So first we're gonna go ahead and learn how to install Docker. All right, so I'm gonna come over here. I'm gonna open a new tab over here, and in Google, guys, go ahead and type Docker for desktop and type in Windows 10 also. So it will directly take you to the link. So the first link is install Docker desktop on Windows, and over here you guys have the first link over here, that is download from DockerHub. Now I'm going to click on this. It's going to open on the next tab, but I have to give you guys a big disclaimer over here that Docker for desktop for Windows only works for certain systems. It doesn't work for all systems. If you're working below Windows 10, forget it. You can't work with Docker for desktop. There is another option. I'll tell you guys about it in a little while. Let's first read through the system requirements. So in system requirements, you need to have Windows 10 64-bit, and you need to have it, be the Pro version or the Enterprise version or the Education version. So Docker for desktop is only available for these 3 versions of Windows 10. But that is Docker for desktop. There is a legacy tool that you can run without this. And for Windows 10, you need Hyper-V and container Windows features enabled. I'll tell you guys how to do this. And rest isn't that required. I'll just tell you guys how to do it, okay? So just make sure that you have Windows 10 64-bit Pro version, Enterprise version, or Education version. What you can do is, you can go to My Computer and click on Properties, and you can check your system details over there. All right, so this is one way. If you have all of this, keep on following. Just click on this download from DockerHub, and it will give you an option to get Docker for Windows. You can click on Get Stable, and it will start downloading Docker for you. Now I'm gonna close this because I've already installed Docker on it, and I don't really need it right now. So I'm not gonna go ahead and pick it up from my system. So this is it, Docker desktop installer. Let's wait for it to open up. Yes. Right. So the process is pretty simple. So it's already finished because I've already have the Docker on my system. So what it will do is it will just ask you, do you want to download? It's just very simple process. Just go ahead and download it. And once this is it's completed, it'll tell you that you're done, and you can click on close. Now the thing is, you have to configure some things for your Docker to run. Your Docker will not run simply. You need to make sure that your virtualization is enabled on your system. To do that, to check if it's enabled or not, what you have to do is do Control Alt Delete and open up your task manager. And when you do open up your task manager, go to performance, and in performance you need to check about virtualization over here. So you need to check virtualization if it's enabled or not. If it's not enabled, then you need to go to your BIOS. Now, to go to your BIOS, I can't really show you guys because then I have to quit out of this live session because it requires you to shut down your system. And if you guys know how to access your BIOS, that's great. But if you don't know how to access your BIOS, what you can do is just type in how to enable hardware virtualization in Windows 10, or type in your laptop. Like suppose, let's say you're using MSI laptop, then go ahead and type in your model name, and it will tell you how to enable virtualization in your BIOS, right? You can type in BIOS also. So generally the process is, you shut down your system, you restart it, and you either press in F1 or F12 or enter depending on your type of your system, and it will give you a lot of options. Go to security, and within security you need to enable virtualization. Okay, so yeah, so it's very system dependent. So you can go ahead and type it over here. All right, so once you've enabled virtualization, you need Hyper-V also enabled. So for Hyper-V enabling, you can open your search bar, type in turn Windows features on or off. And once you click that, it will ask you what features do you want on or what features do you want off. So you'll see Hyper-V over here. If it's not check marked, go ahead and check mark this. And once you've check marked this, you need to restart your system. And once you do restart your system, you need to go ahead and click on Docker Desktop. So these are the two things you need to do. And there is one more error that I faced while installing Docker. If you guys face the same, then follow these steps. So this is the error where it tells you, it's not a error, but it tells you that warning that WSL2 installation is incomplete. So you just need to click on this link, and whatever update it tells you to download, just download that update from this link. So it should look like something like this. You can click on download latest WSL2 Linux kernel, and once you've downloaded it, your Docker should, you need to download it, you need to install it, and once you're done installing it, you can go ahead and launch your Docker. So once you do launch your Docker, it should look something like this. All right. Okay, for some reason it's not loading. Let me try something out. Right, must have hanged. All right, so let's try again. All right, so this message should appear up. Linux containers WSL2 backend is starting. All right. So now our Docker desktop is running. Now to access your Docker desktop, you can either open CMD. This is for the terminal where you can type in your commands. You can open CMD or you can open PowerShell. Now I would recommend using PowerShell because PowerShell is a lot more robust than your Docker for Windows for desktop. I mean CMD. So over here, what we're going to do is I'm going to type in Docker hyphen version. So this will list the Docker version I have. All right, so there's two hyphens over here. All right, so you guys can see over here it's written Docker version 19.03.12. So here we have our Docker installed on our system. So this is how you would install it. Now there is a background dashboard that opens up. If it does not open, what you can do is you can go to your notification bar over here, open it up, and you'll see the Docker desktop running. Right click it and uh, click on dashboard. Now, once you click on dashboard, this will appear. Now, this is if it doesn't open up for you directly. For me, it didn't open up directly, but normally it should open after you install the Docker for Windows. All right, so once you install Docker, it will give you a starting tutorial that you guys can go through. Now, it's not necessary because you're watching my tutorial, so you have it there, you have it going there. All right, so we have installed Docker. Now I need to tell you guys the steps for installing Docker toolbox also. So let me go ahead and show you. So once you're in this page, right, Docker for Windows, you need to scroll down on the left hand side, and in the left hand side please click on superseded products and tools, because that's where you'll find Docker toolbox. Or what you can do is you can click on install Docker toolbox, or what you can do is type in Docker toolbox for Windows, and it will show you basically the first link. You can click on install Docker toolbox for Windows, and this is all the steps are over here. This is for any older versions like Windows 7. Oh yeah, and there are some requirements for Windows also. You need to have Windows 7 or above for Docker toolbox to run. You can't run it with an older version. Okay. All right, so these are the steps in which you basically install Docker and several help applications. So for that, you directly go to Toolbox Releases, open new link, and over here you just need to go ahead and download the Docker toolbox.exe. And once you download it, you can start using it from PowerShell once all the formalities are over for downloading. Okay. Now, if you're one of those lucky ones who already has the Pro version, you guys can follow my steps. Somebody's asked for Mac. I don't have a Mac, so I don't exactly know for Mac, but you guys can go to Docker for desktop, type in Mac, install Docker desktop for Mac, and there is a specific link for your Mac. Okay, just install it from there. All right, so I hope that made it clear for a lot of you people. Now for Linux, I've already made a lot more sessions, so you guys can go and check out those sessions. And also, if you guys are into Hindi and if you want to watch these sessions in Hindi, I've done some sessions in Hindi also. You can check out Docker for Docker in Hindi, great learning. Okay, so now let's go ahead and check out all the processes. All right, so for all of you who don't know what Docker processes are, I need to explain that too. Okay, for anyone who already knows Docker, there's going to be a revision. All right, so we have Docker environment. So basically, I'm going to be talking about all the things that make Docker run. So I'm going to quickly go through this because I really want to show you guys how to use the commands. Okay. All right, so here's the Docker environment where we have Docker engine, Docker objects, Docker registry, Docker compose, and Docker swarm. Forget Docker swarm and Docker compose. They're advanced topics. You don't need to learn them. And we'll be concentrating on Docker engine, objects, and registry. Okay, so engine is basically something that is the core thing. It's about Docker. So it consists of three things: the CLI, the API, and the daemon. So daemon actually does all of the processing. Any request you send will be given to the daemon, and the daemon will run it. Now API is your communication thing. It basically allows you to communicate things to the daemon. And CLI is basically all your Docker commands. Like we typed in this command over here, right? That is Docker --version. That is your CLI. That is a command line interface where you're interacting with the Docker using Docker commands. So let's say there is a user who wants to create certain objects. He will type in the command and it will be communicated through the API to the daemon, and daemon will create those objects and report back to the user. Okay, so that's a Docker engine. And then we have Docker objects. There are a lot of objects like images, containers, volumes, networks, and swarm services. So you don't concentrate on volumes, networks, or swarms or services. They're again a little bit more advanced topics. We'll be just be talking about images and containers. So images are your main thing. So when I talk about sharing a container, I don't actually mean the container itself. What we do is we create an image for that. We have an image for specific containers. Now, to get a better idea of what images are, just imagine an image to be a blueprint. Like whenever we build a house, right, we need some specifications for the house. Like how is it going to look? What kind of paint is going to be on it? And what are the dimensions of the whole house? So all that is on a blueprint. Similarly with containers, if you want to specify exact details for a container, then you need to create an image or use an already existing image to create your containers. So let's say you want to create an Ubuntu container, a container that runs Ubuntu inside of it. So what you will do is you will get an image that has the specification of Ubuntu. So it will say that, it will tell the daemon that, daemon, I want to make a Ubuntu container. The image will tell to daemon, and daemon's like, all right. So he will create the Ubuntu container. So that's what the image is. It's a specification or it's the blueprint for creating a container. So normally when you share anything, right, when you share something about a container, you're actually sharing the image. Since you share the image with all your colleagues, they can just take those images and run them in their own systems to create the container. So they don't have to send the container itself. They just send the image to it. Okay. All right. So now let's go ahead and, okay, I'm going to skip volumes. All right, so a brief idea. So basically, volumes are they're like hard drives. They store since containers can't store data permanently, you need volumes to store the data. Then you have networks, and they're kind of self-explanatory that they connect different containers. If you want to connect one container to another, you make use of Docker network, and you can connect. You can do connections on a very different levels of scales, like overall scale or just local scale. Then you have registry. Registry is a place where you store images. So it's very similar to GitHub where you store your code. So Docker registry is where you store your images. So you can take in 1, 2, 3 images, all of them, you can store them in registry, and people who have access to that specific registry can take those images. Okay. You have a lot of options like DockerHub, that is Docker's own thing. Since Docker is a company, they have their own thing. You can use AWS service or JFrog Artifactory or Azure Container Repository. Okay. All right, so I'm gonna skip through compose. I don't want to confuse you guys. And if you already know, then that's great. All right, so now let's go ahead and do the commands. So first, I've already shown you. Let me go ahead and increase the size for this. All right, so I hope it's a little bit more clear. Again, the Docker command, that was Docker -- version to check the version of Docker you have. And the next command we're going to learn about is Docker pull. So what Docker pull does, it basically helps you to get images. So there, I told you guys about Docker Hub, right? So if we go to hub.docker.com, it's a place where you have all the images for all the certain things. So let's say you want the Ubuntu image, you will find the Ubuntu image on Docker Hub. Somebody's already uploaded. That's the Ubuntu company. They themselves have uploaded the Ubuntu image over here. So it's an official image. You can go ahead and pull it and create containers out of it. So we will pull Docker pull Ubuntu. So first what it will do is it will look for this image locally. So it won't find it locally. So what it will do is it will basically pull it from the library, that is from Docker Hub. And then it will put it in the local system. So once it's put in the local system, you can just type in Docker images and you will see what all images you have. So I have like 2 more images over here. Just concentrate on Ubuntu. Let me go ahead and clear the rest of them out. All right, so we have Ubuntu over here. So Ubuntu is the image that we pulled from DockerHub. It's the latest version, and you can see the image ID that is formed for our local system. It was created 3 weeks ago. That means it was updated on the DockerHub 3 weeks ago, and you can see the size. So someone's kept on asking why is Docker so fast. This is again the reason, the containers, right, that they have created. These containers are going to be of a very small size compared to virtual machines. So here you can see that the containers, the image size is only 73.9 MB. So you can start using Ubuntu for only with only the size of 73.9 MB. Normally, if you look for Ubuntu images, they're like 1 GB or 2 GB or more than that. I haven't looked at one, so I don't remember exactly, but they're definitely more than 1 GB of size. And you can see the clear difference over here. All right, so we have pulled a Docker image. So that was the command we used, Docker pull images. Then we checked out Docker images command that will basically listed all the images. And yeah, so some people have asked questions like, can you SSH into Ubuntu image or Docker? Yes, you can do that. I will show you shortly. And can you tell how you erase the images? Right, so I've showed you guys the images command, right? So Docker images will list the images. And if I wanted to erase an image, so what I will do is, so I will use the command docker rmi. So rmi is basically remove image. So you can go ahead and copy the image name or the ID, paste it, use docker rmi, and it will remove the image. So you will first untag the image and then it will delete it. So if I do docker images again, I won't have anything. So let's go ahead and pull Ubuntu again, because I want to create a container out of it. So it will start pulling Ubuntu again. All right, so we have Ubuntu pulled and it's over here. Now let's go ahead and create containers out of it, because that's the most important part. So docker run. So that's the command we use. So docker run and Ubuntu. Now this is the basic command to create an image. Your basic create a container. You are referencing the image over here by using the run command. So docker run, this tells the daemon that you want to create a container, and then you reference the image. Now we need to add a few more flags over here, like -it and -d. So I've included these flags because they increase the stability of my container. They basically make it interactive and they make it detached. So interactive basically means you can interact with the container, and this flag, that is -d flag, it basically makes my container detached. Okay, so it runs in the background. That's what detached means. Now if I press enter, so you guys can see a big number came up. This means my Docker container has been created. And if I want to see if my container has been created or not, so there is a command called docker ps. It will basically give you the process status of your containers. That's what ps stands for. If I press docker ps right now, you guys can see one container has been created. This is the container ID. This is the name of the image. And this is the seconds ago it was created. This is the up status. No ports. It has not been exposed anywhere. And this is the name of it. Now you might be surprised with the name over here, Charming Agnesi. So this is a randomly generated name. If you don't mention a name when you're creating a container, Docker is gonna create a randomly generated name. So what we can do is we can go ahead and include another flag called name flag -- name, and I'm gonna give this. Let me take a name from the chat. Let's say Rex. Yeah. So this is going to be the name of my chat. So Docker ps, that's again to see which all containers running. If I do docker ps, I have two containers, Rex and Charming Agnesi. Okay, so here we have created two containers, right? And what can we do with these containers? We've already created them. What we can do right now is we can go inside of this container. So it's like SSHing into the container, that is going inside of it. So there is a command for that. It's called docker exec -it and the name of your container or the ID of your container. Go ahead and paste that and bash. So what this will do is basically it will it will allow you to go inside of it. So first command tells daemon that you want to go inside a container. This is a flag again to make it interactive, and to make it interactive using the bash terminal. Bash terminal is like your Linux terminal or your git bash terminal. Okay, if I press enter, you guys can see it has changed from my own system to root at the container ID. So if I do an ls here, you guys can see that this is the Ubuntu, system in Ubuntu system. Basically, all the parts you might see in your home directory in Ubuntu, you can see over here also. Now there is one more thing I can show you guys. Let me exit out of this container right now. Let me bring up the dashboard, because in Docker, you will, with Windows, you will be working with the dashboard. And in the dashboard, you can see something cool that you don't see with Linux. That is to see your containers that are running. So you can see my two containers running, Rex and Charming Agnesi. And I have a lot of options with it. Like I can open the CLI, that is the command line interface. This is when you click on the CLI, it basically execs into the container. That is, it opens up the container. Instead of typing that whole command, it will directly do it for you and open up a new window. You can just do an ls. You can see the same thing over here. All right. And you can stop this container over here without typing a command. So if I just stop the container over here, it would have stopped. You can see it exited. Now if I do a docker ps over here, I can see that there is only one container, and that is Rex. Okay. So now if I want to see my exited container, I can go ahead and type in docker ps -a. It will list all the containers. So with ps, you only see the running containers. With -a, you see all the containers, whether it's running or not. Since this is exited, it's no more running. Now, if you want to start it up, you have two options. You can just go ahead and click on start over here, or you can, type in the command docker start and your container ID or your name. So it will start it up. Now, this is the generic command you would use. But since we're using Windows, let's utilize the privilege we have of using Windows. I'll come back and I'll just click on start over here. And you can see it's running again. And if we go ahead and remove this command, docker ps, and you can see that our container is up and running again. So that's pretty cool, huh? All right, so we checked out how to do this. You can go ahead and remove your container, delete it from here, or stop it, or if you want to restart it, it will restart the container also. It will exit it and start running again. But if I want, I can delete containers also. So if I want to delete the Rex container, it will ask me, do I want to? I'll click on remove. And if I do a docker ps now, I don't see the container anymore, even with -a. With -a, you normally see stopped containers. Now, to do this with the terminal, you can type in docker rm-f and the container ID. So it will remove your container. So you can go ahead and paste this. It has removed the container. If we do docker ps, no, nothing. All right, cool. So I want to show you guys a few more commands over here. So let me go ahead and run Ubuntu container again. Again, you guys can see the syntax, docker run -it-d. If we do docker ps, you guys can see a new container with a new name, Nostalgic Maxwell. All right, so we have created a new container. Now, if you want to stop it, again, you can use the stop command. But if you want to forcefully stop it, you can use docker kill command. So it will also stop a container like how your stop command does, but it does not do it so gracefully. Okay. All right, so we've learned a lot now. Let me go ahead and remove this image also about the containers. Now, before we end the session, guys, we're going to end the session in about 5 minutes. So go ahead and shoot your questions in the chat while I show you the last cool thing that we will do. Okay. So let me go ahead and run an Nginx container. So for that, I will type in docker run -it-d. I'll give this a name, my web, and let's say my container, and I'm going to mention Nginx. I can go ahead and put latest because I might want the latest. By default, it will take the latest tag. So when you mention colon, after that, you normally mention the version of the software you want. You don't need to mention latest at all. It will by default pick up latest. So if I press enter, what it will do is it will first look for this file locally. It can't find it locally, so it will start pulling it from the DockerHub. All right, so wait. What I wanted to do was a little different thing. Well, all right, so this container is created. Let me go ahead and delete this because I wanted to do something else. All right, so we'll run this again, but this time I'm going to add something new, that is -p 8080. So what this does is it launches my Nginx on the port 8080. Now 8080 is basically exposing the container at 80 and exposing the system at 80. So my system will expose Nginx at this particular ports. 80 is default port. So if you just go localhost, we should be able to see Nginx. So if I just run this, and if I do docker ps, you guys can see the ports it's available at. So it's showing 00080. So if I just open up my browser, type in localhost and press enter, I can see welcome to Nginx. Cool, huh? All right, so we basically learned how to do this. Now you can do this over here also. So my content is running at port 80. So there is a specific new option over here that is open in browser. That happens when you are using Windows. So you get an option over here. Just go ahead and click on open in browser and it will open it up for you. All right, so I hope that was clear for you guys. Now, how much time? We have a few more minutes, so let me go ahead and explain the Docker architecture. This will basically explain all the things I've done so far. Like, let's say in the Docker architecture, you have a CLI, you have the host, and you have the registry. Now, let's say you have all of this. So Docker CLI again is the command line interface. That is, you putting in the commands like docker build, docker pull, docker run. Now we did not learn about docker build. That I'll save for another session. So what build command does is it basically allows you to build your own images. So when you type in docker build, you do so while having a docker file. So docker file is basically used to create an image. So whatever specifications you want in your container, you will have in your image. Now to create an image, you have to create a text file in which you write all the specifications. So let's say we wanted to all right, so we don't have nano command in this. All right, so let's say basically we had a text file. In that text file we wrote from Ubuntu and we build that text file into an image. So while we to build that text file into an image, we have to use the docker build command. Once we type in the docker build command, the docker daemon will read it. It will read through the docker file and it will create an image accordingly. Now, what docker pull command does is it basically tells the docker daemon, I want an image. So it will see that, if you have the image or not. And if it sees that you don't have the image, it will go ahead and check in the docker registry. Now, the default docker registry is basically DockerHub. So it will look over there. And if it finds your image, so let's say you were opening Apache web server, you're pulling that. So it will find that image and it will replicate it into the local server or local system. And then you have docker run command. So docker run command basically tells the daemon that you want to create an image. So let's say you specify the Ubuntu image. So docker daemon will take that image and it will create a container out of it. So this is the basic Docker architecture. All right, so guys, that was it for me explaining to you about Docker for Windows and what Docker is. I hope it was very helpful. Now, I assume you guys have typed in the questions you want. All right, so I see a lot of questions. So I've already answered, can you SSH into Ubuntu image? Can you tell how to erase image? I've already explained that, Docker RMI. Where images stored? So in your local system, there is a specific location where your images are stored. And on DockerHub, it's stored in a cloud. Okay, so it would be Ubuntu container and not a VM, right? Yeah, Aftab. So you're right. So it would be an Ubuntu container, but not a VM. You will not be able to access any GUI because there are no GUI components in that container at all. Can we run Unix on Windows using Docker? You can try. I have not tried that, but you can see if there is a Unix image in DockerHub, then you can go ahead and try. So let me go ahead and check that. Maybe we do have. All right, so we don't have any specific ones. So Unix, it forms a base for most operating systems. So I, assume that they don't really have an image for it. But let's check Windows. So if I type in Windows, we do have image for Windows Server. So you guys can see if you want to make use of Windows Server, then you can go ahead and pull the image. If you want the pull command for them, just go ahead and open these images, and there's normally a pull command in the the front page of the image. So how are resources like RAM, CPU, and CPU allocated to the containers? So that is done through the kernel, through the Docker daemon, right? So when you create a container, you tell the container that you want to create a container, and the daemon, right? It will basically allocate those specific resources by by accessing it through the kernel of the host system. All right. Okay, my internet is slow. Otherwise, we should see it over here. The option to pull it. Okay, let me answer more questions. We can see again this video. Yeah, you guys can definitely go ahead and see this video. So this will be uploaded later for you guys to watch on our channel. So subscribe and not miss out, right? All right. So Piyush, you've been asking how to install Docker on Red Hat Linux. So that procedure, right? To show you that procedure, I'll have to sit down a little bit more, but we don't have that much time today. So how about this? I'll put your this thing request in my to-do list, and we'll try to come up with a session for exactly Red Hat. Or maybe if I do Docker tutorial again next time, I'll do it in Red Hat instead. How about that? All right. Okay. So I see no more questions. So I'm giving you guys like last 1 minute. You can still go ahead and ask your questions. After that, ending the session. All right. So I don't see any more questions. Maybe it's because of the lag, but I think it's time for us to end. Anyways, guys, so thank you so much for watching. I really hope that you got something out of this session. I really wanted to make this session very interactive. That's why I asked you guys to keep on asking questions. And if you guys really enjoyed the lesson or the session, go ahead and put in the comments. Put If you have any requests, go ahead and put those requests in the comments. We always read the comments. We always try to come up with sessions based on what kind of requests you guys given. And if you really like the session, please go ahead and give me the love in the comments also, and like and subscribe. That also helps us a lot. So guys, thank you so much for watching. I am Ram, and I'll see you guys in the next session.